Good morning, everyone. Welcome to Virtual Brew by American Innovations. If you are just getting settled in,
Welcome, everybody. Thanks for joining us this morning. My name is David Gaucher. I'm product manager, and I primarily look after our PCS platform as well as survey manager and a lot of the points where our applications either integrate with each other or integrate with other applications. So today we're going to talk about that topic right there, specifically around integrating remote monitor data. And we're going to kind of walk through things. I like to think about things from a mental model perspective. So we're going to follow the steps that y'all should take. The initial steps as far as aligning a remote monitor to a facility in PCS. What does that mean? How do you do it? How do you align the channels in that monitor to fields in PCS? What does the import look like? What's required? Where do you need to make some decisions? And then we'll focus on a little bit about repeatability, how to automate your bridges and ensure that you're getting the right records in each month or each day, however often. At the very end, we'll kind of talk about one of the places where we see problems. It's around unit swaps. It's very common for misalignments to happen there. So without further ado, let's talk about linking remote monitors to facilities. I'm going to start by just kind of talking about PCS in general to get everyone up to speed. So PCS has what we kind of think of as a facility-centric view of the world. And really, the places that you're required to visit, the test points, the rectifiers, the bonds, those places that you're going to on an ongoing basis, either annually or monthly or bi-monthly, we call those facilities in PCS. Because PCS is a database, it really does not like to have duplicates, right? Duplicates are a big problem with databases, make it really hard to query your data, to run reports, to find what you're looking for. And so we have these IDs that are on the back end that we're not really going to talk about that help with that from a technical perspective. But for folks that are using PCS, we have what we call Intel key fields. And the Intel key fields, you can actually see them in the screenshot in the top right corner here. Row code and pipe, milepost, and facility ID. That's just a screenshot of the data grid from PCS. And those column headers are emboldened to indicate that they're Intel key fields. What those do, the Intel key fields, is we combine them to make something unique in the application. And so, the standard way that this happens is through like test points or foreign bonds, or galvanic anodes, and it's combination of the row code or segment code. So what pipeline are you associated with? And then where along that pipeline are you? What's your milepost? The combination of those two things, along with the facility type, makes a facility unique. And if you're familiar with adding data to PCS, you might see, windows that appear and say, hey, you're making a duplicate facility. Are you sure you want to do that, right? The same idea applies to rectifiers, but rectifiers are a little bit different because they're what we would describe as a many-to-many relationship, right? So they can influence the potentials of multiple pipelines, either directly through negatives, through electrically continuous pipeline segments, even through bonds, foreign bonds. And because they have this many idea, we also require a facility ID for rectifiers. That's why it's emboldened on this screenshot. So a facility ID, what it really is just a description that allows you to describe where a particular facility lives. And the focus is not on the rectifier make and model. That may change over time. It's not the RMU itself, but it's the geographic location where that rectifier lives. And then you're attaching a remote monitor to that. And the reason I'm giving all this context is because in order to link a remote monitor to a PCS facility, what you're going to do is make sure that the facility ID on PCS matches your facility ID on your remote monitoring website. It's as simple as that. Once those two are linked, then we know what facility we're at. And there's some parameters and some best practices around facility IDs, right? So it's alphanumeric field, which means it can have numbers and letters. It has the capability of including some special characters like hyphens or underscores, pluses. So you can use those as well. And then, the big thing is that it should be unique, right, across all facility types. And we're going to help in a lot of respects. We're going to tell you if you're inputting a facility ID that's not unique, but it's really important when you're even thinking about other facility types, rectifiers, test points, and bonds, that the facility IDs are unique across those types of facilities too. And that comes into play when we talk about facility key bridging, which we'll get to here in a little bit. Facility IDs should also just be descriptive. They should describe the thing that they're attached to generally. So it's clear when you're looking at a facility ID, this is what it is. This is actually, now that I'm looking at a terrible example, the facility ID is a serial number of the remote monitor, which really doesn't tell me much, right? I have to rely on things like the location description to determine which facility it is. And the reason that's so important is because when you're going to map these guys together, it's really helpful to have descriptions so that you can, properly place the remote monitor with the right facility. Okay, so we have an understanding of how we're associating remote monitors with PCS facilities through the facility ID. Now we have to understand the channels on those remote monitors. How do we associate those to PCS fields, right? Channels are not smart. They're not self-aware. They are just capturing what they are told, and they don't really know they don't really understand what they're capturing, right? Sometimes it's easy to label a channel because these remote monitors can be pre-configured. My channel 1 is always my volts. My channel 2 is always amps. And so I just need to make sure that I'm wiring it up correctly when I'm installing it to make sure that my volts are in channel 1, my amps are in channel 2. But other times, remote monitors aren't prescriptive about which channel is which. And so, there could be cases where channel 1 is volts, channel 2 is amps, or the opposite. Channel 1 is amps, channel 2 is volts. You can also have times where you blow a channel, right? Channel breaks down and you have to switch to channel 3 or channel 4. In any case, PCS needs to understand what kind of measurement data the channel is reporting on. So how do we do that? With bullhorns, we use something called the engineering unit. And you can see that here in the top right corner. We have kind of default engineering units that already align with PCS. So for volts, rectifier volts, it's going to be DC_volts. And then that same label is applied to the corresponding field in PCS, rectifier output volts found. And so when we're pulling in the report from Bullhorn over the API, we can recognize this measurement has this engineering unit, DC_volts, that matches the engineering unit on this field. And now PCS knows exactly where that data should live in PCS, right? So that's how we do it with bullhorns. Now, if you're importing other types of RMU data, then you're not going to use an engineering unit. What you're actually going to use is an Excel spreadsheet, either a CSV or an XLS format. And we'll talk about the format that we require here in a little bit as well. But the structure of that spreadsheet is really important. And specifically around your RMU channels, the thing that is most critical is that all of your volts readings are in the same column and all of your amps readings are in the same column. Because similar to how we're mapping with engineering units, When you're manually importing from a spreadsheet, we're going to say this column, which has my volts, maps to my rectifier output volts found field. And this one that has my amps is going to map to rectifier output current found. And that's how PCS is going to understand where those readings should live. So in order to have all of your data in one go, you need to have all of your volts in a single column. They can't be split over multiple columns because there's a one-to-one relationship between a PCS field and a column in an Excel spreadsheet. Either way, if you're doing it manually, if you're using the engineering units within Bullhorn, moral of the story, you need to label your channels, and you should be consistent about how they're labeled so that it makes it easy to integrate with PCS. Okay, we have an understanding of how to map an RMU to a facility, and we have an understanding of how to map channels to PCS fields. Before we do anything else, and before you do anything else, always, always, always verify your alignment before you do any sort of bridge import. Like think about, okay, over the last month, I swapped these 2 units out, or I installed this new RMU. I'm going to just go through and double check and make sure that they're aligned before I generate any reports or try to run bridges, because it's so much easier to make the changes ahead of time than after the fact, right? If you already import the data to PCS and then realize that it's misaligned, not only do you need to go back and clean up the systems so that subsequent imports are correct, but you're also going to have to go through and clean up the data in PCS, right? Because it could be mapped to the wrong spot. And then, if we extrapolate that, a lot of times PCS is connected to other systems. So if I'm pushing data to GIS every single night and I don't catch the problem, well, then I have bad data in GIS now that I have to go clean up and figure out. So the problem can kind of expand really quickly. And the solution is to just be diligent about making sure that your alignment verification is done before any of the integration actually occurs. Okay, shifting gears, let's talk about the flavors of bridges that we have, right? So the way that we import bullhorns is a little bit different than the way that we import through the standard bridge with Excel spreadsheets. And actually, in PCS 2.5, we included a ton of enhancements around importing bullhorn data to PCS over a new API. It's too much detail to cover in this presentation, but definitely get in touch with someone at AI, your point of contact, that can walk you through the enhancements. Some of the high points and how we're doing things today is we're aligning things smartly. So if your facility IDs match on both sides, on Bullhorn and PCS, then we know which rectifier the RMU is associated with, right? And if your channels are labeled correctly, then we're also going to know where the fields, the measurements should go, right? And if that is all done ahead of time, then we auto map everything, and everything's great. But we're humans, and that doesn't actually happen, right? So in cases where the facility IDs don't match, we offer recommendations like, hey, notice that the latitude and longitude on this remote monitor is really close to this rectifier that you have in PCS. Maybe they're the same facility. Do you want to map them? And we offer suggestions like that, right? We also provide a single place for you to align the facilities on either side, right? So the PCS facilities with remote monitors. So rather than having to switch between 2 systems to see what's my facility ID, okay, copy and paste that into this website. Now I need to run a report and make sure I got it. There's potential for errors if you add additional spaces on either side and things like that, fat fingering things. With PCS, you're pointing and clicking, and then your alignments are saved for posterity. It's fully automated on the Bullhorn bridge. So because we understand the data on both sides, we understand where it lives and where it should live, we're able to make requests and pull data in a fully automated fashion. You don't even have to think about it. And then the last thing is that we're proactively identifying misalignment issues to make it easy for you to correct. So if you had a remote monitor that had facility ID 1, 2, 3, and then that was attached to or associated to a facility in PCS that had facility ID ABC, we're going to call that out and let you know, hey, these facility IDs don't match. Are you sure that they should be linked together? And it's okay, if they are, we'll let you do it, but we're going to call it out and make it easy to highlight those places where you might have some problems. Okay, now thinking about things from importing remote monitor data from the standard PCS bridge, you're going to use a flat file in Excel. A flat file, it has a pretty rigid format. So the first row has column headers, right? The columns are going to match to PCS fields. And so my first row identifies what the name of the column is and what field it should map to. Below that, you're going to have rows and rows and rows and rows and rows of data with no gaps. Okay, so we know that we have to have our measurements in the same column, right? Volts and amps all need to be grouped in the same column. The other things that you need are your facility ID, so we know which facility it's associated to, and then inspection date and time. And you can add other stuff if you wanted to. A lot of times when we import data with the Bullhorn bridge, we include something in inspection remarks that says this reading came from a Bullhorn, just to make it easier in reports to know those readings that were captured manually versus imported from a remote monitor. So the format is really important. Fortunately, you can use the same format over and over and over again, right? And that's how you kind of build the automation piece on the using the standard bridge side of things. As far as aligning the data, it's kind of manual, right? There's some things that are going to be helpful to you. For example, using facility key bridging, and facility key bridges are a special kind of manual bridge that let you validate only based on facility IDs. So you don't have to have the pipeline and milepost information. It just says if my facility IDs match, I'm good to go. We also have a bridge preview that is going to highlight in a nice, pretty color-coded way if you have places where your facility IDs don't match, places where you have readings that are out of range, but then you still have to go through and manually clean those up in the other system and rerun your exports. And then because we're talking about reports, files that are created, they're snapshots in time, right? The files have to be moved to a place where PCS can access them, which is typically behind your firewalls, managed by your IT. There's a manual nature of getting the report data to where it needs to be to really get full automation. Okay. We have an idea of which bridge you're going to use, right? If you're using Bullhorns, you're going to use the Bullhorn API. If you're using other RMUs, or you just prefer to use Excel, you're welcome to use the standard bridge. Now I have to think about, from the remote monitoring side, which records I want to include in my report. And so really you can boil this down into kind of a couple use cases. The thing to focus on is how often do you need the readings, right? So most of the time, when we're reporting data on rectifiers, you're looking for compliance readings, right? That's either going to be monthly or bi-monthly, depending on your O&M. If your O&M says monthly, then it's monthly, right? So you don't want every reading from that month because it's just kind of noisy. So typically you're going to get the latest reading, the latest good reading from that month, and that's all you want to include in the import. Now, if you are doing a separate kind of use case, for example, like an AC current density study, you probably don't just want the one reading because it's not going to give you all of the information you need to understand how your AC is influenced throughout the day or week or however long you're doing the study for. You probably want all of the readings, right? All of the measurement readings. And so just kind of keep that in mind. Those would be two separate reports or two separate extracts with two separate bridges that are run in PCS. And it's important to kind of think about that ahead of time so you know I need to build these reports on the remote monitoring side to import to PCS. Something new.
To go.
We have 2 minutes left. So we have an understanding of how to generate reports for remote monitors and why you would do that. And then let's talk about automation really quickly. First things first, with the Bullhorn API, you can fully automate it based on an interval of your choosing. Typically, what you're going to want to do is kind of like the example I gave just on the last slide for rectifiers. For monthly or bi-monthly readings, you're going to run those every month or every 2 months, however often you need, and your automation is going to align with that, right? And then if for AC type readings where you need more data, you're going to run that maybe even on a daily basis or weekly basis, as often as you need the data. It's important to think about your exports though, and group them together from a verification standpoint. So if I have monthly rectifier imports, right? Every single month I'm importing 241 rectifiers. And then maybe I have annual test points that I'm going to import as well. The one time a year where you're importing the test points, don't mix that in with your rectifier imports, because when you're looking at record counts, you're going to look each month for 241 records. It's good, it's good, it's good. Then when the test points come in, you're going to have a ton more records, and it's going to make it kind of hard to understand if all of the rectifiers made it in. So keep those things separate so you have a good understanding of your verification on a month-to-month basis. And then lastly, just at a high level, talking about unit swaps, this is where we see most of the problems with misalignments occur. The scenario is I go out to the field because my RMU stopped reporting. It's got a problem. I need to send it in for repair. So I'm going to put in a new RMU. And if you don't go through the steps of making sure that you are reassociating the new RMU to the facility ID where it's attached, and then removing the old facility ID from the old RMU, then you can run into problems where units are reporting on the wrong data because the facility IDs haven't been updated, right? And so we have some tools in Bullhorn Web that you can see here. The replace tool is how we do that, and it swaps all the data, makes it super easy. It's definitely should do it before you go out on the field though, so that those initial packets that are captured, they report to the right place. And that's it. Sorry for the technical difficulties, y'all, but had to finish up pretty quick there at the end.